Hi folks, I welcome you back to Global Education Zone, and today I will be teaching you guys how to draw the plan and the true shape of a sphere cut by a plane as shown. So in this case we have a sphere. Now the first thing, this is the front elevation of the sphere though. Now we are going to extend this elevation downwards and we are going to draw the plan of the sphere. So this being the center line, I'm going to draw a straight line down to locate the center line of the plan. So now I'll draw the plan for the sphere at any suitable radius. But the plan of the sphere will still be the same. Alright, the plan of the sphere will still be the same radius, not any suitable radius, but the same radius as the elevation of the sphere. Now, after drawing the front elevation of the sphere cut by plane AA inclined to the horizontal plane and the outline of the plan. So basically, this is the outline of the plan. Then we need to draw the front elevation of the sphere. Now this sphere has been cut. This sphere has been cut by a plane. So now this plane is plane AA. Now this plane AA is a plane through which the cut has been occurred. So we have the plane AA. Then from A to AA. Now the next step is to draw a semicircle on the section. So now this is a section of the plane AA. So I'll draw a semicircle on the plane AA. So this is a section through which this thing was cut. So the sphere has been cut through this section. So basically, I have this section. So I will draw my what's called the bisector, and through this, the center of this bisector is what I'll use to draw the. Is what I'll use to draw the. Now the next step is to draw a semicircle and divide it into 6 equal parts. So now I will divide the semicircle into 6 equal parts and project these points perpendicular to the section. So now there's an easy way of doing this. Just cut this two sides. So I want to draw the divide into 6 parts. So now I'll divide into 6 parts, and then I'll draw these parts. I'll join them with perpendiculars to the section. So this is the section. I'm going to draw lines perpendicular to it through these 6 divisions. First division, second division, third division, fourth division, fifth division. So the 6th division is still there. Alright, next step, let's call this number 1. Let's call this number 2. Let's call this number 3. Let's call this number 4. Okay, let's call this number 1. Let's call this number 3, number 2, and number 1. Let's call this plane B, and this B. Now the reason for this is that this side, when viewing from one end, they'll basically be on the same level. So that's why we have this 1 and this as 1, 2 and 2 and 3 at the top. Now the next step after doing that is to project the points perpendicular, which we've done. Then the points from the points on the section projects vertical lines downwards. So from this point on the section, I'm going to project lines vertical. These are the vertical lines. So I'll project vertical lines downwards. So now all the vertical lines downwards being projected downwards. That's the vertical line being projected downwards. All the first vertical line. So I have the second vertical line. Of the third vertical line being projected downwards, of the fourth vertical line projected downwards, the fifth one projected downwards, then the sixth one, and finally the border. This is one of the ends of the section. And next step, after projecting them downwards, you take the width O1x, O2x, O3x, and O4, and then we are going to place this each side on the center lines of the plan. So basically, these width, they are going to be like this. When we draw a horizontal line, through the center, when we draw a horizontal line through the center, we have them here. So now we will need to transfer these distances from this center to this. We're going to transfer these distances. Let's see. These are on the cut. So we're going to take the width O1. Well, first of all, we need to draw a a shape here. So let's call this O1. So this should be O, since it's the center of this part. This should be O. So this should be 1. This should be 1. Let's call this 2. That's 2. And this should be 3. Let's go on to call this one 1. So this O, this is 1. This is 2, and this is 3. So we're going to transfer this width to the vertical, because in a sphere, your vertical and your horizontal lengths, they are quite similar and equal. So I will draw a vertical line, then I'll transfer this width from this center of the circle to the vertical. So from O to 1, I have it here. From O to 1, this from O, open the compass from O to 1 here. So it's at 1 now. So I'll cut it on the vertical. Then we'll have from O to 2. I also cut at the vertical. Then we'll have from O to 3. O to 3. Also cut at the vertical. Then we'll also have. So this time I'll start measuring other way around so that it will be accurate. So from 3 to 1, all you need to do is transfer the distances, the relative distances. So you can start from any points. From 3 to 2 is being transferred. So from 3 to 2, then from 3 to 3, this from 3, then open to 3, which is the outer edge. 3 to 3, transfer it. So let's call it, this is O, 1, 2, 3, and 1, 2, 3. Now transfer them to the horizontal plane. We'll make horizontal projections of these lines, and it's through these horizontal projections that we're going to have what's called, have these horizontal planes. So they will form the true shape of this figure. Now, after doing that, we'll be able to form the true shape. All I need to do is connect O to O. Yeah. So basically, so this will be O to 3. This will be the extremes. So I'll also have the extremities here. So you just need to connect them. The intersections of each of the horizontal components to its corresponding vertical. So we have them here. I'll have this here. So, yes, O to 3. So I think this 3 to 3 is quite exaggerated. Maybe I think there must have been a mistake from here to here. 3 to 3. Okay. So this is the actual length. You do something like this. This should be a mistake. I noticed that it was wider than normal. So we have we'll have this here too. Have this here. This is the second, and this is the third. And so okay. So we'll draw a line through all these points, and that line will determine the path of the curve. So the curve is supposed to look elliptical. So I think it should be from here. So then we can now draw a curve. So you can, I'll make use of my hand today because of time. So drawing a curve through these points. It's supposed to look elliptical. That's if you are drawing yours. So I know it is not perfectly elliptical, but it is close to being an ellipse. So now we have so I've taken the front elevation for you to know that this is actually a sphere, but this sphere has been sectioned, has been cut by a plane. This sphere has been cut by a plane. So this is also the plan. So you can see it very well. Now, finally, the last thing to do is to obtain the circle, which is the true shape of the section. So I'll take half the length of this section BB. I'll project it at an angle. So let me just project it at this angle so I can see it from here. So this circle will form the true shape. So the true shape of this kind of shape of this is a circle. So I'll draw a line parallel to this one here to the center. And then from here I would draw a perpendicular to this line to obtain the radius. So this will be the radius of the true shape. So I'll draw a circle that corresponds to the true shape. This circle gives us the true shape of this section. So this true shape, this is a way of drawing a true shape of the section of a sphere. You don't need to draw perpendicular to the line, just draw a line at any angle and then draw a line parallel to it in such a way that the distance between those lines is half the length of that truncation. So and this will make use of section lines because this is a true shape. So this is true shape of a truncated surface. So that's why we're making use of section lines. So I know this is supposed to be at an angle though, but because the true shape is already at an angle to the plane, so that's why I'm taking it horizontal. So this is basically how it looks. So this is the front elevation of the truncated sphere. This is the plan, and this is how it looks on the plan, and then this is the true shape of the truncated side. So thanks for watching.